Hi everyone, welcome. My name is Mia. I'm one of the producers for TOMOFest, and we're really excited for this session. This is the show and tell ML and AI project Share Lightning Talks. So it's our second round, and we're really excited to get this one started. Your host today is Darren Pluchak, taxonomist and NLP practitioner for TechTarget. And we have several presenters today that you'll hear from. Thank you for sharing your projects. A little bit about structure. Each speaker will have 2 minutes to share their project, followed by 10 minutes of discussion. So we'll be keeping time. And before we get started, I'd like to take a second to thank our sponsors for their support of TotalFest and today's session. And also just a quick note, since today's session is hosted on Zoom, please note where the chat is and feel free to send any questions through there. We'll be monitoring. And if you're watching on YouTube, we'll be checking the chat there as well. And so that's all I got. I'll hand it over to Darren.
Hey, this is Darren Pluchak, and the way we're going to run the lightning shares is we're going to go in order of the agenda. So let's do a screen share real quick, and I'll just show the agenda here. And so each person will start by please saying your full name, who you're affiliated with, and where you're located. So, and then you'll have 2 minutes, and I want people who are on this session to be thinking about questions to ask, because the point of the session is to draw out what we find interesting from the person's work, and even their life if you want. So, whatever you want to find most interesting and strikes you as maybe partially explained or things you want to further pursue, please be prepared to ask those questions, and we'll get started right now. Edgar, you ready?
Ready, steady.
Okay, go for it. Take you please share your screen if you can.
Yep. One sec. Okay, share.
Okay, starting your time.
I need to move this little thing away from here. Okay, hi everyone. I'm Edgar Roddale. I am a data science consultant and a founder of an analytics engineering consultancy, Brave Tech. I also work as a data scientist at the Future Society, and based in Barcelona, originally from Estonia. And today, then I would like to discuss analytics engineering, which is let's say, a rather newish field in the data ecosystem. And what it comes down to is essentially preparing data. Most companies these days have a data warehouse, and it's either BigQuery or Snowflake or Redshift or anything like that. And they also have like tens of 15 or tens of 20 or however many different data sources coming from Salesforce, HubSpot, Marketo, analytics, also emailing tools, A2B, A/B testing tools, etc. So there's loads of different data collectors. And collecting all this data, that's usually then stored in a data warehouse. And then the question is, what's the most efficient way to make use of that? So, and then a newish tool that I've become quite liking is an open source tool, is called DBT, Data Build Tool, and it's developed by Fishtown Analytics, based in Philadelphia. And what this tool does is it brings software analytics, software engineering best practices to analytics workers. So
hey Edgar, sorry, we got a lot of people, so I just gotta say that was 2 minutes.
Shit. Oh fuck. Okay.
But I'm sure we'll draw out more information on the tool. So anyone have any immediate questions? Help guide Edgar in explaining more. Someone can ask a question. Come on, just speak up.
Hey, this is Sam. Edgar, there are a ton of tools in this space. What is particularly interesting about this one?
Right. So this tool allows you to essentially, so like this is, for example, like a what typical data warehouse looks like. So if an analyst is not using DBT, this type of view is usually missing. So every green node here is a source table. Every other node is some type of data transformation. And that will then lead to like a reporting table, a table that a data scientist would use for their modeling, etc. So, and let's say you make like you do like an edit in a source table like this, and then you want to know like what are all the downstream data models and dashboards and analysis that are going to be affected, and then you can immediately see this. And then what DBT allows you to do is to run all your tests all at once, right? So all of your data models, you run DBT test, and then by making one change, you can run DBT test, and all of your downstream data models will be automatically tested. And that's something that is not really seen a lot in analysts' work today.
Would you compare it to a declarative approach in a lot of like software, like data ops or something? Because I see that, not from this diagram, but you write SQL queries and then somehow they're bound together, right? Can you explain that side of it?
That's right. So yeah, each of these nodes is essentially a complex SQL query, and they're all then linked to each other. So, and often you make data models, and then they're all dependent on each other, but this like overview kind of lacks. Or I don't know if that answers the question.
Sort of. When would you use this instead of Airflow?
Yeah, because it's specifically geared towards analysts. So Airflow is super engineering heavy, for example, whereas DBT is then it's really then for analysts to understand like the model dependencies, the set up different tests of their models, to set up alerts, all this work. And Airflow is really more like a workflow orchestration for data engineers.
Okay, questions, folks? Has anyone else here heard of this tool, used it, used other similar tools?
I think I heard you mention this before, and I thought you were saying DVC, which is another open source tool, data version control. There's also tools like Pachyderm, and then tools that are focused on like the feature store. Angle, Tecton comes to mind. Have you looked at or worked with any of those? I think they all of the ones I mentioned are like commercial open source products. So there's a open source angle as well.
Yeah. So yeah, they're all slightly like different purpose. So what's the purpose here is to perform the transformation inside the data warehouse. So it doesn't load the data to warehouse, and it doesn't extract it. It just purely deals with the transformations inside the data warehouse. Whereas like DVC, for example, yeah, is a data version control. Haven't used it myself, but it's what I understand is that you can have like kind of Git style versioning of your data. So yeah, they're all slightly different purpose, and the data warehousing paradigm is something that has been changing how enterprises like keep, store, and analyze their data. So then this tool is then specifically geared for that purpose.
So the main person in the case would be someone who's a data analyst, like you said, right? And maybe they're producing a dashboard, and they're analyzing and manipulating a bunch of data to get that dashboard. And this creates a reproducible environment that they can create using SQL queries without any code, and then track and test, right? So that's the core of the use case for this?
That's right, yeah. Yeah, you pretty much summarized it.
So really it's not really for data science use case, which is more of some of those other tools that Sam mentioned. Not that it couldn't be used for that, But
Yeah, so data scientists then often like they would pick it up from here, because data scientists then they would like require a data in a certain format, or in a certain way, like that you would have like, you know, deduplicated and like tested that all the like the columns and the dimensions and the definitions are right, and then you create like a model like this, and then the data scientists can start taking over from here and start performing their modeling. So it's almost like it can be a precursor in this case.
In your use cases, how much of those transformations are you trying to do in the data warehouse versus in further into the data science pipeline?
So good like aspect of doing those transformations in the data warehouse is that you minimize your engineering workload, right? So you can do like you can transform millions of tens of millions of rows of data in a couple of seconds in SQL. Whereas if you do this in Python pandas, like you need Spark, and Spark again is an extra step in engineering. So that's kind of one benefit of that. And yeah, and often like those some simple processes can be done like where the data is, so you don't have to pull it out and load it back in, basically.
yeah, so this is for a repetitive pipeline of sorts. So as a data scientist, I'll be experimenting in, you know, pandas and maybe use Spark and do hyperparameter tuning and all that kind of stuff. But then, you know, if we start going into production or I find a repeatable process, it's good to move it back in the pipeline in this explicit way that I could see it and test it, but it's using SQL, and because it's probably a repetitive thing or process. So, anyone
That's
else?
right.
Questions? Yep.
And I'll keep asking questions if, so go ahead, Dinesh.
Okay, so the question, so I'm assuming this is for the database, for the table. How does this track, does it spit out any lineage? I can see from right to left that it is showing the dependencies. So let's say if I'm changing a field on the right side, does it spit out the impact on various artifacts so that you can see the impact analysis on a changing on the right hand side to a left hand side or left to right?
Yeah, so yeah, it's essentially used on a command line. So it's a command line tool, and then you can with different types of commands, you can then like most of it works through testing, right? So you have tests in place, and then you can test like a particular data model and all of its parents or all of its children, and then you see the effect through that. So and you have to create tests for that, and if you have done that, then you see the effect through that.
Can we use this for sort of like analysis, as I was saying, to see a change? So if you want to make a change at a one point, what's the impact of that change is going to be to a downstream downstream applications, or where we are feeding in?
I think again, probably the answer is testing. So, or if I'm just thinking how I would do that, like yeah, if let's say like this is like a HubSpot a data source, and then we make a change inside HubSpot, so then that gets loaded to the data warehouse, and then we want to see how this is impacting like this model. Yeah, you would create a test for that, so to see like kind of like the previous setup with the compare with the new setup and spit out the difference, and then you see the difference in the individual rows or summary statistics, or how you'd like it, and that would all then defined in SQL.
Hey, I think that's all we have time for. Thank you, Edgar. You know, just seems like a super practical, useful tool. I'm pretty sure.
And it's simple, and it's simple.
Yeah. Great. Thank you for introducing that to everyone here. So let's move on to the next presentation. And Kamal, you ready? Please remember, say who you are, who you're affiliated with, and where you're located very quickly. That's all we need, very brief, so you can get into the heart of
sure.
your Thank you.
Yeah.
Okay, and take the screen over, please, and then we'll start. Once your screen is sharing, we'll start the time.
Oh yeah, sure. And I couldn't start the video. Could you please enable that?
What's that? Yeah, you could show the chart you have or whatever, the diagram.
Yeah, sure. Oh, hi. Thanks for the opportunity. My name is Kamal. I'm from Infosys, and this work is done with my team, Abhijit Das, who is also from Infosys, and Sounder, who is a lecturer in RKM Vivekananda College. Typical neural networks do not leverage domain-specific information because they are heavily dependent on data. But 3 years back, researchers came with this special type of neural network called physics-informed neural network, which can also leverage the domain-specific information. And so you needed lesser data, lesser compute, and lesser time. What we are demonstrating here is that we are visualizing the learning of the neural network when the prior information is not explicitly enforced, like in traditional neural networks, and the learning of the domain-specific knowledge when it is explicitly enforced, like in physics-informed neural networks. I quickly share the screen. Yeah, you can see the plots. The top plot represents the accuracy. That means it plots the difference between the predicted value and the actual value versus time. And the accuracy of traditional neural network is represented in red color, and the accuracy of the physics informed is represented in green. The bottom plot represents the learning of domain specific knowledge, the learning of the domain specific knowledge. In this case, I've picked Berger's equation as the domain specific knowledge. Berger's equation is a fundamental nonlinear partial differential equation which serves as a domain specific knowledge for many models. And so for this demonstration, I picked Berger's equation, and this is the Berger's equation. And what we have plotted is the difference between du by dt and the rest of the parts of the equation. I'll just play the series. As you can see, the red area in the top plot indicates the accuracy of traditional neural network. The red area in the bottom.
Sorry.
Okay,
2 minutes. I'm going to be interrupting everybody. I'm sure it's like impossible to stay at 2 minutes. So, so questions. I think people in the audience, please help Kamal explain more in the direction we want him to explain. So, go ahead and ask questions, even basic ones, please.
So, okay, question.
Yes.
It was still unclear for me. So how do you embed, what part of the modeling process embeds the domain knowledge in there, and how is the domain knowledge represented?
Oh, fantastic question. The domain knowledge are typically represented as a partial differential equation, right? So when I drop a ball, and if I don't consider domain knowledge, it's just like collecting all the historical information of what happened when I dropped the ball. And domain knowledge is the gravity, the equation gravity, right? So like that, for any use case, if there is a domain knowledge, if there is a prior information, that is represented as a partial differential equation, either as a linear partial differential equation or as a non-linear. But they are the physics laws that the model is supposed to honor. And so in these neural networks, they add those partial differential equation as part of their loss function. And so your model is forced to honor those laws during the training. Did I answer your question?
Yeah, that answered. So then I'm wondering if, like, because then you're not like 100% optimizing it for the data, you're keeping continuously like the domain constraint, right?
Oh yeah, correct. You are
and
right.
Then
actually.
and then how does the validation then, do you still validate on like ground truth labeled data like the same way, or does that somehow work differently?
Yeah, right. Fantastic question. So the point is, I'll just explain the question for the rest of the audience also. Traditionally, right, regular neural networks has a loss function where it tries to calculate the loss, the difference between the actual value and the expected value. It wants to minimize that loss value. That's what traditional neural network does. And I said we were going to use these PDEs as a loss function. And so the question is, then that means, are you compromising on the learning on data, correct? So the answer is, the actual solution is your loss function will still contain your traditional loss function, which is like mean squared error or whatever, right? So it will contain that equation. In addition to that, they will add this PDE. So your loss function will look like the predicted value minus actual value plus a partial differential equation. So we are actually forcing the neural network to honor both. But having said that, still there is a compromise, right? You can still learn more about the PDE and can compromise. You can learn lesser about the matching the data, right? But overall, we force the model to learn both on the accuracy part, the difference between the actual and the expected value and the PDE.
So which data set you have used to model this particular neural network?
Oh, yeah. Right. I'll answer into two. I'll give two different answers, actually. Number one, the authors who introduced this concept called physics-informed neural networks has actually used a data set, and I've used the same data set to demonstrate this visualization, so that I mean, I don't want to introduce data, my own data, to really just to prove a point, right? So and so I used their data and use it as it is. But what did they use, right? So if you don't use a partial differential equation, if you do a regular neural networks, we will have a lot of data. But the data that they use is that they did not use all the data. They just use the boundary conditions, right? So how did the model perform? How did the time value is minimum, and when the time value is maximum, and when your radius is minimum? So they use only the boundary conditions, and I also used only the boundary conditions and the partial differential equation to demonstrate this.
So same question on top of it is like which physical domain information is combined with this data? So I just want to know the data comes from which physical domain. So what is your PDE basically in this, or is it a random data, right?
Okay. Yeah. Right. So the PDE that we use is a Burger's equation, and Burger's equation serves as a fundamental PDE for variety of problems, correct? And we didn't pick any specific problem data. We just, they created a synthesized data and used it and use it on the Burger's equation. So the PDE that we use is a Burger's equation.
Okay.
And all these things are possible because so the TensorFlow and languages like Julia have introduced this automatic differentiation. And so it's possible for us to calculate these derivatives and do these plots. For me to plot this, I need a system which can calculate du by dt and du by dx. And this was not possible before the automatic differentiation was supported by Julia and TensorFlow. And so we were able to demonstrate this in a forum like this.
Can you relate this to a task and how it might improve an outcome, or change an outcome, or change how you analyze or understand an outcome?
Oh, yeah, right. So before this, right, before I came to know about, I was forced to know about this because I was working on a problem, and before this, and I start training it, when the accuracy is poor, right? If it is not up to the mark, if it is not state of the art, I keep trying, probably changing the hyperparameters, increasing the layers, or increasing the neurons, or decreasing it. I was just playing with the neural network architecture, but without having an insight on what actually was learned in the neural network, right? So I was, suppose if you give me any problem, I'll search for a similar problem's neural network architecture and actually feed my data to that architecture. And I will actually change few things that I can optimize, right? I can tune. I do that with minimal knowledge. But otherwise, there was no explainability on what did the model learn, what it did not learn. It was a vacuum. We all know that, right? So that was a problem. Now, because Now I have a PDE, and especially the reason why I built this visualizer is that in this visualizer, I'll just play it again. I mean, I don't know, it's too short time to really comprehend from the demo. In this visualizer, I can see that the red area indicates that it's a poorer accuracy. And in the bottom also, it says that the PDE is not honored. So that sort of convinced me that probably they are linear, right? So whenever the PDE is not honored, the accuracy was poorer. So that's when it gave me the confidence that, so okay, then when I enforce the model to really honor the PDE, there is a chance that it might improve on the accuracy. And so these are the situations where I am forced to use the PDE. But the downfall is that, again, right now at this point, if you look at all the research solutions on this, it all apply to the physical systems, right? The turbulent flow systems like that, which already has a prior information, the fundamental physics laws. I could not find an option to use it for a non-physical systems because we cannot generate a PDE that a system should honor, right? That's one part of the story. Second, changing the loss function. I mean, defining a loss function is a little complex because a loss function needs to obey a lot of properties, right? It has to be continuous and it has to obey a lot of mathematical properties for any equation to become eligible for a loss function. A linear or a non-linear PDE naturally becomes eligible to be part of a loss function and so it becomes easier for us to use this also.
Okay. We have just a minute or so. Any other questions? More questions? So were you able to improve your model based on this empirical data information?
Oh, yeah. So I was able to. So I picked the same example.
All right, Kamal, I think we've kind of losing you. We haven't heard what you just said the last couple of minutes, and time is up. So we're going to have to go to the next presentation. But thank you. Sorry. Okay, so we're moving on now. We got Brian.
I mean, I use a
Kamal.
just
Kamal.
visualized just under to the bandwidth. Yeah, is it? Can you?
Hey, we're going to have to move on to the. Yeah, no, your voice is messed up, so we're gonna move on to the next one. Your time was up anyway, but thank you very much for the explanation and the work. So we're ready for Brian, and don't forget just to say your name, your affiliation, your location, and maybe the title, and go for it. And
great.
Thank you.
Hey everyone, my name is Brian Romas. I'm an aspiring data scientist. I'm actually looking for full-time positions, so if anyone's looking for a new data scientist to join their team, please feel free to reach out. I recently graduated from the University of Michigan, finished my master's degree there. And what I'm going to talk to you guys about today is a pretty straightforward project that I worked on around collaborative filtering. So let me share my screen. Great. So as I mentioned, this is a project focused on collaborative filtering specifically for patient recommendations. I was given a task and given some randomly generated data. The data was basically a list of patients and their procedure histories. Their histories were represented as ICD-10 codes. These are just codes that represent medical procedures. And I was asked to explore the data in some way and generate some insights from it, basically. So I use this as an opportunity to explore collaborative filtering because that's a technique I haven't really worked with before. And I ended up using the surprise library, which it's very straightforward library to use, and it will help you establish help you quickly establish a baseline for generating recommendations. So you can go through some of the details that I have here, but I basically went through a pretty typical machine learning type of workflow where you're creating some sort of a baseline model. I evaluated a couple candidate algorithms because the surprise library has a number of baked in algorithms you can just pick and choose, kind of like scikit-learn. For those of you who aren't familiar with it, the surprise library is a SciPy library, so it's very similar in nature to scikit-learn. There were a couple nuances specifically around creating training and test data sets, which if you end up playing around with this, you might want to spend some time on the surprise library's features for generating training and test sets. But I was able to go through...
Hey, Brian, that's 2 minutes.
Okay, great.
So, yeah, so let's get some questions here so we can guide the discussion further. Even very general questions.
So very general questions. So as you mentioned, you use surprise libraries instead of scikit-learn. Any specific reason to use that, but you keep saying it is kind of same?
That's a good question. The surprise library is kind of tailor-made for collaborative filtering type tasks. So it would be, it's the right, I think in my perspective, it was the right tool for the task, for just creating a baseline model.
Okay.
And you were also saying that it's similar the way you use it to the affordances. The way
Right.
you use it is similar. It's like sort of modeling the same kind of objects that and classes that
Right.
scikit-learn uses. So
Yeah,
if you're familiar with scikit-learn, surprise is easy.
Between the two.
Yeah. Were there other libraries that you were aware of, or other ways people do this?
No, and in my experience, this is kind of like the baseline. If you're going to do anything with collaborative filtering, like and you're in the Python world, then you would start with surprise. I don't know, maybe there are people in the audience who are familiar with more sophisticated approaches and more sophisticated libraries. So if anyone knows, please, share your thoughts or different approaches that you guys have taken. One nice thing.
Brian, I didn't quite get the use case. What are the patients? Sorry, Brian, I didn't quite get the use case. What are the patients recommending in this case?
Yeah, the idea, good question. The idea was, it was a pretty open-ended scenario, but it was basically, here's some data. You might be a challenge that you might run into in an organization. Like, we're an organization, we have some data, but we need to find some value in the data. So it was very open-ended on purpose. And what I decided to do was try to leverage the collaborative filtering techniques, which is what you would use in like a recommender system. The idea was, can I spot some patients where we should recommend a certain procedure to them based on their history, or based on how similar they are to a patient that has a similar history, basically. So it was to get them.
Okay.
It was basically to get them the right medical treatment. Is the idea.
So the entities you were matching were people and treatment, right?
Right. It was
and
people, so it was a patient and all their medical procedures that they've ever had, basically.
Did you find there were certain features were you able to identify if there were certain features that helped a lot in that matching between the patient record and the treatment?
That's another interesting thing about this approach, is that I didn't really need much in terms of data. If you look at so this is the surprise library, and this is really what the library needs. This is the data that it needs. It needs 3 columns, basically. A list of users, a list of items, and ratings of some sort. The way that I got the ratings here was I just did a simple count of how many times that patient has received a certain treatment or something like that. That kind of became like the rating for it. But you don't really need much. You could potentially add in more features, and maybe if people have done this elsewhere in applied scenarios, they could like share their thoughts around this. But this was all that you needed here.
Looks like the optional parameter is timestamp. So how would that be used?
Yeah, that's a good question, because the data that I had was just, there was the sequence of the procedures wasn't really taken into consideration. It was kind of like almost in a sense like a bag of words. It was just everything mixed together, right? So order didn't really matter. I did not play around with the timestamping, but I imagine that would help leverage that additional information there.
Were you able to mix in content different techniques, or is it all collaborative filtering? Like I've used a tool where you can actually use it, somehow mixes the content similarity or content-based matching with the collaborative filtering-based matching.
I know that is some additional sophistication you can add into collaborative filtering, which is because one challenge that you have there in general is the cold start problem. Like, if you have a brand new patient who has no history, what do you recommend to that patient? Similar issue is if you have a brand new procedure, let's say, or a brand new movie, if you want to expand this and talk about recommender systems, how do you start leveraging that new patient information or that new item in your collaborative filtering techniques? And I think, generally speaking, it's easier to find similarities between the items. So between a procedure and another procedure, or like this movie is very similar to this movie. It's easier to do to get past that problem using those types of techniques than it is to get by it saying Darren is very similar to Brian, is very similar to Edgar, type of approach. But so I know that exists, Darren, but I didn't have to leverage that here.
What did you think about your results? Is it promising? Would you try to use this tool again?
They seem promising. It's hard to say because the data was all randomly generated. So it's hard to really know if this was accurate, really. But I used just a mean absolute error to assess the performance. And it was about, it at least allowed me to create a list. I could then create a list of an n-numbered list of like recommendations. So I could recommend the top 3 or the top 5 or the top 1 procedure. And I think that at least allowed me to give me the flexibility to offer, here's a whole list of possible procedures, instead of saying like, here's the one and only one procedure to consider. Good questions.
So is this only limited to the medical procedures, and did you try any other area or on other data sets?
It's not limited just to medical. This is a pretty general, collaborative filtering is a general enough technique in when it comes to recommender systems. So any place where you want or need to generate recommendations based off of, essentially, as long as you have individuals or people and items that you want to recommend, you can use this. You could use collaborative filtering, and as I mentioned, within Surprise, there are a number of algorithms that you could pick from. There's k-nearest neighbors. There's SVD. I ultimately used a non-negative matrix factorization, which was kind of that was new for me, but I discovered that was the best performing algorithm through that machine learning iterative like evaluation process, the training, testing, evaluating cycle. So yeah, you could apply this in a number of scenarios where you want to make a recommendation.
Yeah, I mean, isn't the fundamental thing of collaborative filtering you're leveraging other people's judgments? So you're saying this person, you have similar reading habits to these group of people, therefore you might be interested in the other things they're reading. That's sort of the fundamental piece of it.
Right, exactly.
So the question was, did you try anything else except the other one data set?
Sorry, no, I didn't apply this to anything else. It was just for the one task, for the one data set.
Okay.
But
yeah, I mean, it's been used widely, though. Yeah.
Well, I was just going to mention that is an important consideration because let's say you had a list of patients, a general list of patients, and you had a subset of patients that all had a serious medical condition. Let's say it was like a small subset of special patients. You would probably have to rerun what I did, at least in my code, And because some of the values I ended up hard coding in this code here, like the number of factors that I used, and then matrix factorization. In the general scenario, you might have more factors available that you would want to leverage, whereas in this smaller subset of patients that have very particular histories and very particular medical issues, you might want to use maybe a smaller number of factors, or the factors might be different.
Oh, okay. Thank you, Brian. That was great. Appreciate it. And we're going to go on to our next lightning share. Fatma, please say your name, your affiliation, share your screen first, and go for it. There you go. I see your screen now. I don't hear you though, Fatma. You there?
Yeah. Can you hear me?
There you go. Okay, we're all ready. Go for it.
Okay, great. Hi, everyone. I'm Fatma. I'm a research associate at the University of West of Scotland, in Scotland, in the UK. I am here today to share with you my work on explaining birds' attention. My project is to detect cyberbullying from social media platforms and raise an alert to people in charge to take an action. I have tried different models with different complexity on different data sets. So in this graph here, we see on the x-axis different data sets from different social media platforms with different sizes. And on the y-axis, the F1 score of the model. On the right-left side, we see right-hand side, sorry. We see different models with different complexity, starting with sample, logistic regression, MLP, LSTM, by LSTM, and finally BERT, fine-tuned, and BERT without fine-tuning. And the results show over different data sets, BERT fine-tuned is the best performing. So the next step was why BERT is the best performing. We tried to understand that. And we used model explainability. We used an algorithm called integrated gradient algorithm to do this model explainability. Integrated gradients algorithm measures something called feature importance. How important certain feature is in the model's final decision to predict a comment as contain bullying or not. So if we want to visualize it in a simple way, this is the integrated gradients algorithm. We feed it with our fine-tuned BERT and a sentence like feminists are feminazis. We find that the algorithm, the integrated gradients algorithm, assigns a certain score. It's called sometimes feature importance, other times called feature attribution, how much this feature, this certain word attributes to the final prediction. And positive score means that this word contribute to the positive label. And in our case, positive label means contains cyberbullying. Negative.
Sorry, Fatma. That's 2 minutes.
It's
can you
2 minutes, so I'm done
yeah,
already.
Yeah.
Okay, so to wrap up quickly, we did that feature importance score, and we compared it to the internal feature attention weights generated in BERT's fine-tuning, and we correlated between them, and we couldn't really find a correlation between the feature importance score and the attention weights of BERT across different data sets. We only found that the words that occur the most are the words that receive the highest attention weight from BERT. Thank you. Any questions I have? I can share with you the code. It's already on GitHub, but I have the notebook open here, just in case you have any questions.
So it seems like basically the attention did not explain what you saw. So is that correct? So is it sort of a mystery why BERT performs well?
Well, we still don't understand regarding text classification tasks or tasks that include only one sentence. what is the role of attention weights. So my results are in line with other results that found that attention weights don't really explain the performance. And here I'm referring to papers like attention is not explainability, and another paper found that the attention weights make sense when the input to the BERT model are 2 sentences, but if it's only 1 sentence, attention weights don't really they don't give us an explanation why the model performs in a certain way.
Okay, questions, everyone? A lot more information underneath it you can explore. Questions? Okay. Well, let's get a little more context to this. So, why did you do this, and how's it going to guide your practice or your next research?
Well, I think model interpretability is very important trend now. Especially, we have been working with deep learning models as black boxes for a while, and we need to understand why models make certain decisions. And maybe because of the same trend, people could find that BERT is big, but we don't need all those attention weights, and we don't need all these attention hits. If we make the model a bit smaller, then we can get close good results with way less computational power. And we could, that only was made available because people worked on explainability. And in my experiment, I wanted to understand the same, but for cases like cyberbullying, because most of the cases covered in literature are sentiment analysis or some of the off-the-shelf datasets, but there are some datasets that are not really explored in the literature. And that's what I'm doing here with cyberbullying datasets. So the next step would be, okay, now we see that BERT is the best performing, but the attention weight don't really make us understand why the model is performing the way it is. So my next step would be to dig deeper inside the attention weights and the attention hits and prune the model to fit cyberbullying cases, and in the same time get a model that is smaller in size, but it performs also well. So I think that's really important for the environment, and this is my next step in research.
Fatma.
Yes?
What is your definition of cyberbullying?
There is no one single definition. It's one of the disputed things in the literature, that there are different definitions. But basically, it's using electronic form to harm a group of people or an individual. So if you use social media to harm a person, like targeted to one person, or harm a group of people, like homosexuals, for example, then that is considered cyberbullying. It takes different forms like sexism, racism, aggression, but they are all fall under the big definition of cyberbullying.
So why is feminazis considered high in the index of cyberbullying?
Because this word is an indication of cyberbullying, because it's an offensive word to feminists. That's why the word has high weight towards the final decision of the model, because the model was trained on data that contains similar things, like words like feminazis, and assaults towards feminists are considered cyberbullying.
So is that something that that corpus of words is input as high in cyberbullying, or does the system find that out? Humor me here, I don't really
No, this is a supervised machine learning training. So I feed the model set of data set of comments labeled as cyberbullying or not, containing cyberbullying or not, and the model learns from them.
Okay, thank you.
Hi, Fatma. I have a question.
Sure.
Yeah, so I'm very new to NLP and I haven't worked on BERT at all. Are there any limitations you came across when you started working on your project? Like,
Sorry, can you repeat the question again?
sorry, yeah. Were there any limitations? Like, did BERT, when you worked with BERT, did you come
Any
across any
limitations?
limitations?
Yeah,
Yeah.
well, there are some limitations. First of all, computation power. Working with BERT to fine tune, even just fine tuning, not pre-training. If the data set is big, like bigger than 100K, then it will take long time to train and to dig deep into model explainability to generate something like word importance, or to generate something like what is the attention weight of certain words. That will take up to 12 hours running on a GPU. On a small GPU, it's not like larger GPU, but just the GPU fits on my laptop. But yeah, this is one limitation. Second limitation is BERT uses something called word pieces to tokenize the words into smaller pieces. So the model can compare certain words to something called vocab text that the model have seen during pre-training. And while I was trying to find the attention weights and the importance score of these words, some words are broken into sub-tokens, and I couldn't put the word together back. And that's limitation in my research, in the results I showed with you today. So yeah, I haven't figured out how to put a word together, like a tokenized word using port piece together, so I can calculate or measure the attention weight or the importance score of the word as whole. That doesn't happen with all the words. It's only with words that can be tokenized, but other words they are fine. They are the same. But that's one limitation I found working with BERT.
Thank you so much. I can imagine why that would be a problem.
Thank you.
Yeah,
Thanks
I think this is really cool work. So thank you.
Thank you. It's been time is up. Thank you, Fatma. That was interesting, and I think it'd be interesting to see how your research evolves. There's so much going on with explainability, and it has so many uses as well. So that's great.
Thank you. I hope that was useful.
Okay, definitely. Thank you. All right, let's move on to our next one. After the next one, we'll be into our backlog. We have two people. We might get to them. We're going on not quite an hour here. So, Encrypted, are you there? Are you ready? Please share your screen.
Yes, Darren.
Great, excellent. So please introduce yourself real briefly, and we'll start and share your screen, and we'll get started.
Yeah. So let me share my screen. Hope you guys see it.
I see it now.
Yeah, so
yes,
I'm Ankit, working in urban networks as an expert engineer. Recently, we started looking at machine learning stuffs for the networking. I'm very new to this area, and this work is very simple, not even neural network based. It is very combination of a statistical supervised learning model with what you say is unsupervised learning. So the problem statement we came across, the problem is the route tables are very important in the enterprise network, and then any drastic change in route table may lead to problems like black holing the data traffic and then shutting down complete site, right? And these are some citation I have just put. I'm not going to read it because you can find it over the internet. So happened recently, like some BGP routes was pumped into ISPs, and then a complete site was black holed. So the work here is to understand how can we really find it via machine learning, right? If something is changing drastically, because BGP being a very old protocol and they have different way of extendability, routes can come, import, it's all more manual effort. And then route table gets bigger, and then sometime you have applied ACL, you may not be able to, or import, export measures, it may not stop something which is coming new, right? So main funda behind is the routes are stored in a Patricia tree. Patricia tree is a special kind of radix tree customized to save the space. I will not read more about that. Probably that can be found on internet. So what we do, we extract feature from Patricia tree, normalize that, cluster them, and find the clusters and centroid points, and store them in a database with timestamp and model them. So basically, if you see a few of the features are listed, like number of vertices, edges, leaf nodes, height, more dense height, most dense height, number of vertices on the most density, like at the most dense height, how many number of vertices are present. And then you model them and find the cluster ID. Some data sets are given below, which some random data set we tried. So if we normalize that data set, we get these values, and then the cluster ID is assigned to it. So below the pictorial representation of how per cluster ID the values are varying. So this data can be fed into a time series database and then can be modeled to every time when we get the information of number of features, how it is varying, right? And the right side you see centroid point variations for every time run. Then the normalization technique generally I have used from the Python scalar library like min-max scalar at this point, but you have many other mechanisms like z-score or something can be used. A lot of things to explore here, not completely done to say. And the outcome would be like you find during the period of time if there is some drastic change, you may alert it like as an anomaly, and that can be treated quickly or checked quickly to not bring the complete internet down or site down. And the one statement I would say, like generally those things are found within hours or days, like something went wrong and then why I'm not able to route to the internet. So that can be reduced.
Thank you. That's 2 minutes. We'll start on the. That makes sense. Good. Let's questions.
Yep.
I know we're covering so many different subject areas. It's hard to have, educated questions here. So were you able, what triggered this research, and were you able to apply this? Is it mostly a learning exercise? What's your next step?
Yeah, so as I said, I'm very new to this area in the analytics and machine learning. So this was a learning exercise, but eventually we are planning to get some analytics on our devices. Right, we have wired switches mostly. So while we are finding ways to run basic analytics, which can really run on hardware devices which are deployed in the network, not very high performance servers they are, but they are networking devices, and generally those are Linux devices running some Intel CPU or ARM CPU. So that's where we are trying to find some ways to run analytics from the network data or the traffic information to get anomalies out of the network or behavior from the network to really tap that particular area of business where that is kind of not addressed yet.
And Kit.
Yeah.
I have a question. You were mentioning that you feed the results into a time series database in order to alert on anomalies. What products do you know there? What do you use, or what do you recommend as a time series database? Because I never heard of time series databases until now.
Yeah, so there are time series databases, right? So what happens? You can store some number of values at every timestamp, right? And then it will help you plot the historical data. So you can very well find it over the internet.
Can you name?
Those are flat databases.
Yeah. I'm sorry. Go ahead with the question.
Alan. I was just going to ask that question. Are all anomalies bad?
Yeah, that's a good question. So yeah, the correction measures are still in progress. So sometime not all the anomalies are bad. But if you take in terms of routing table, which we have presented here, the anomalies are bad. So in general, in the stable network, you may not see a lot of route changes happening. But if there are a lot of route changes happening, it is definitely an anomalous problem. It's definitely an anomaly. Because it is going to eat up the CPU, it is going to degrade your network behavior, quality, everything.
So Ankit, I think, do you think that this signature which you are trying to tap, or you're trying to learn using the machine learning, will have relation to the network experience at large scale in big campuses, or with all this in network, right? There's been a complete change in the paradigm of the network usage in the COVID time, and most of the people are online. And do you think that is there a way that you are trying to look at the small routes which control the overall network experience? If one is more flappy, you want to say that these segments you can replan like that. Is that something that you think of?
Yes, that is definitely possible, but that is a different line of thought. I think the question is more in terms of a particular route, if it is going up and down, right? Uh, but here the presentation is about on the overall change in the route table. So if there are few route table changes, I think that may not be too problematic. But we are looking at from the internet route perspective, right? Suppose, so as you said, COVID, most of the people are working from home, then you are definitely connecting to enterprise data centers to access your internal servers. And if your ISP router has got internet routes, and which is trying to and then which gets deteriorated over the period of time, or immediately due to some reason, you have thousands of workers which are not able to access your data center, and then your productivity goes for toss, right? So that's a big problem,
Okay.
which we are trying to tap with this.
Thank you.
Okay, I think that's time. Thank you very much, and let's move on to the next person. So, all right, Ashwini and Preeti. Sorry about that. Are you all ready?
Yeah. Yes.
Okay, let's go for it.
Yeah, so Preeti and I, we graduated last year, and we have put together a little project specially for this, actually. So we are new to NLP, and while exploring NLP, we decided to focus on text summarization. So I'll get to that. We put together a slide for you. Yeah. So a little bit about our background. We're familiar with casino analytics, retail analytics, CPG analytics, insurance analytics. NLP is completely new to us. And we were influenced into this because we saw our colleagues work with customer service analytics, social media analytics, and selecting research paper based on a particular keyword, stuff like that really caught our interest. And we saw NLP applications on a day-to-day basis. We saw LinkedIn and Gmail recommending what to say next, and chatbot interactions. So that's what got us into this headspace. So yeah, we decided to experiment with text summarization. Again, unlike a lot of folks here, we're very new. And yeah, so the first thing we did was we looked into text mining. We're like, okay, text mining is something where I can get meaningful information. Then we saw, okay, NLP is something that can, help me understand what I've been deriving through text mining. So that's how we started.
Yeah, so when we started with text summarization, so this was a thought that came to us while we were traveling to work. So we use this app called InShots frequently, wherein we read all the news articles, right? So there you get about 60 words, which summarizes the entire article. So what we were driving here is, we were very inspired with that, and we were okay, you know what? Let's try text summarization. We are very interested in NLP. Let's give this a shot. So that's how we started. And currently we're focusing on extractive summarization, because in extractive summarization, it just basically picks out the important sentences from the articles. So that's what we are driving to do in our model so far. So this is our process flow. So we basically have a data set which we took off from Kaggle. It is a text summarization data set wherein you have articles, bunch of articles and summaries with that. And with using that, this is what we have done. We have done a bunch of pre-processing wherein we have used expanding contractions, sentence tokenization, stop word removal, lemmatization, and coming to the feature extraction.
Yeah, so what happened is we took our data set from Kaggle, around 4,000 articles. Then for feature extraction, we considered for now title feature, sentence length, sentence position, term frequency, and similarity score. There are a lot more features we can explore, and we're going to get to that after this. Those are like our next steps.
Yeah. So right now,
sorry. This 2 minutes is up. So
okay,
are there any? Yeah, you'll be able to describe more. So what's any questions from anyone?
I have a question.
Yeah.
Right. So how do you evaluate the output of this text summarization model?
Okay, so what we have done so far is, so the data set that we have, right? We are after doing pre-processing and using all these features. Right now, in the feature set, we have basically broken down all the articles into sentences. So for each and every sentence, what we do is we basically compare with a summary. So our summaries are basically extractive summaries, wherein they have random sentences from the article itself. So our feature set also has a column, which is basically the column which we'll be using for classification. So there we basically look at each and every sentence in the article and map it with our summary and see if that is there in the summary or not. So based on that, we have like classified these sentences as 1 or 0. And after that, we have basically ran some algorithms, learning algorithms. And talking about learning algorithms, as of now, we have used Weka, which is an open source tool wherein you can experiment with, machine learning models, visualizations, and pre-processing. So we use this because we wanted to understand, which direction to take, which model to proceed with. We were not clear about that, so that's why we used Weka to understand, which one to do and what to do next. So, does that answer your question?
Yeah, definitely. Thank you.
Okay.
You said Weka, W-I-K. What is that?
No.
WEKA, Weka.
W-E-K.
It's a data mining tool. Yeah.
Yeah.
Yeah, it's been
So
around a long
Weka
time.
works well. Sorry.
Yep. I said it's been around a long time. That tool. It's a good tool. Yeah.
Yeah.
Sure is. Yeah. So
But okay, there's one question I have.
Okay.
When you have, see, the biggest challenge with NLP is very hard, right? Everybody knows it. Like the question is like, when you really apply on, let's say, a new paragraph, let's say the discourse summary of this call is being there. How would you summarize this? Let's say you guys spoke for 10 minutes. What do you expect out of that summary to come?
Yeah, so that's the challenge here, right? We are focusing on extractive summarization. So wherein we are dependent on having a existing summary para for this, wherein we are going to like compare it and understand, will this particular data set be able to summarize that way or not? So we'll be validating it. That's what we are doing right now. But we want to actually get there. We want to do abstractive text summarization, wherein it will automatically summarize the entire session that we are doing, or entire topic that we're talking about here. That is something we want to do, and that is what we need guidance from, like guidance from you guys. If you have worked on it, please give inputs on what to do next.
Yeah, we can show you what we've got, like some of the scores we got from our trial runs. Of course, these aren't perfect yet. There's a long way for us to go. We've just got it started. So these are some of the algorithms which we got results for. These are some of our numbers. You can see it better as like visualizations. It's easier to see it in a graph, right? So based on this, we're like random forest is probably the way for us to go, because we seem to. I mean, of course, we need to explore more features, do a lot more feature engineering, but.
Yeah. So okay, understood. I think one thing which I have to probably, if you ask me a feedback, the way I will say is like we'll all be more curious to know like what is the unknown data sets that is there, and try to get more and more insights about why it predicted what. Means the language part is also very important, like your tooling part, which is the machine learning part, and the way that like the other person asked, right? I think I don't remember his name, but then how do you evaluate that outside of the validation data set? All those are important, but good work. All the best.
Thank you
so much. Yeah, we were really inspired by Fatma's work and a lot of other works. Like we are looking forward to like head back and check them out after this. So we wanted to use this as a platform to reach out to you guys, ask you for guidance, so that what more can we do like from here? Like how do you think we can move forward? If you have any ideas, please let us know.
Yeah, that would be very helpful.
Does anyone else have any actual experience at work or in a competition, or in a hobby project at all with summarization?
See, Darren, I had one experience which I want to share. That whenever we are following the NLP with OpenAI, right? That alien text, whatever is the company, they have the web portal. It's fun, right? You just keep giving paragraphs to it. It keeps creating the output. I think the input output, if you just keep doing, I think NLP requires more people to more see from the input output, and then try to say where it is not contributing, where it is contributing, or where the research direction should go. So any work around NLP, I find it very exciting. I think there are a lot of open source tools which are available, state of the art, which you can experience like API. And even Google, they have put their NLP things, right? I think that
Yeah.
will give us more, to hunt the research is very efficient, is what I found in my experience. To follow the
Yeah.
site subject, right?
Yeah. Thank you. So currently we have a sarcasm detector in place. Like we are working on it. It's not giving really good results right now, but it's a work in progress. But yeah, we'll connect with everybody at the end. And if there's any NLP work, we'd love to connect with you. Thank you. Thank you,
Yes,
Darren.
guys.
Thank you, Madhu, for
Okay.
helping us.
Thank
Sure
you.
thing. Thanks for sharing, and keep up the good work. All right, let's go on to the next presentation. So this will be our last one, scheduled presentation. So Nitin, are you there?
Yes, Darren, I'm here.
Okay, I'm sorry, I can't hear you very well. You have to speak up or adjust your mic.
Hello.
Go speak again, please. Yes, it's kind of quiet though.
Oh, can you give me 1 second?
Yeah, go for it. Sorry about that.
Hello, I think it's better now.
You there?
Hello, is it better now?
It's pretty much the same. Keep trying.
Hello, is it better?
I think so. Why don't you share your screen and we'll see. We'll give it a try.
Sure. So yeah,
It just came up for me.
okay, so you're able to hear me, right?
I think so. So I think it's good. Keep going.
Okay, thanks. So I'm Nitin. I'm working in Hewlett Packard Enterprise from India. So today I'll be presenting about encrypted traffic malware detection. So basically for our modeling, we've used features based on packet length. So I'll directly go into the feature engineering that we did. So yeah, there are already a few existing features like minimum packet length, maximum packet length, mean and standard deviations. So there's this tool called netmate, which when we run on live traffic or any PCAP files, gives us the output of these packet length features. So but we tried to model on these existing features and we were not able to make much progress with it. The model was not performing well. We were not able to identify any patterns in the data. So we decided to add few more features to it. So these features are called steps and toggles, and also a number of unique packet lengths. So if you can see in the slide, the sequence, right? Basically, let's say the first packet has arrived with the packet length of 40. The second has arrived with a packet length of 540. So this is an increase in the packet length, and it's called a step in forward direction. So the next one is a step in backward direction because the packet length is decreased. And this is also a toggle, right? Because it was moving in the forward direction, but then it changed its course. So these were the features we've introduced. And adding these features to the existing packet length features, they've modeled on k-means and dbScan. We've seen better results on both k-means and dbScan, especially on dbScan. It is more relevant for us because we need not specify any. I mean, initially we need not specify the number of clusters. So, so it is better on dbScan. Yeah, we've basically compared between benign datasets and malware datasets. On benign datasets, the number of clusters were very less and the number of noise points are also were less. But when we run the same model on a malware dataset, the number of clusters increased drastically and the noise points also improved a bit. So that means that our new features are influencing and finding new patterns in the dataset. And especially when it's a malware dataset, we are able to find new noise points that might directly correlate to malware datasets. So yeah, that's where our work is right now. We might have to look into supervised learning also. This is unsupervised for now, but supervised might help too. I have few open-ended questions also, but I'll take yours first, and then we can go over mine.
Okay, thank you. That was good. Good summary. Great. So, do we have questions? So is the point of the clustering to try to? I mean, can you envision seeing using the clustering in a to identify particular patterns, to find malware traffic, or do you think it really needs to be the clustering points you towards maybe bootstrapping into a supervised learning problem? But
Yes. So
yeah.
Yeah, so we've used this just to understand if the features we've created make any impact on the data set as such. Because if once we know that these will have an impact, we can actually go ahead and make a supervised cluster, because supervised model, because supervised model to get the data is not easy, right? We need we need flows that we know are malware. We need to label them. And there is a lot of effort required. And so first, if we understand that the attributes that we've introduced, the step, the toggle, and the number of unique packet lengths, if they're making any sense, if they're identifying any new patterns in the data set, that will encourage us to go ahead and make supervised modeling as well. So that is the purpose of it.
Yep. So I see you could use the clustering to do initial sort of data discovery and find some interesting clusters, and then maybe term it as supervised, and then as you could use it as surveillance on an ongoing basis to find new sort of patterns, and then you could also turn those into a supervised if needed.
Correct. And also this can even be further explored to say if there is a data set with multiple malware flows, right? We can actually, if a similar type of malware is classified as one of the clusters, right? It is going into one of the clusters, and we can actually classify indirectly all the malware data sets also. And we can always with the DB scan results I told you, I've shown, right? So here in benign data sets, that is when there is no malware, it isn't identifying many patterns. It is able to only create 3 clusters out of it. So this can be like a signal to some admin when there are so many clusters formed, and when there is so many noise points, you can understand that there is something going on with the data. It's not clear. It's not like expected. Yes, supervised learning would have a label and would be clearer, but this could also help to make the initial triaging as well. I think. So yeah.
Okay. Questions? Ideas? Thoughts?
Yeah, Nitin, I think I have one question. I think, the feature engineering which you highlighted was more, it was can you go to k-means, what you had said? I think it was able to create more number of clusters, right? Which means you are able to more finely mine the patterns that is there, right? Which means like if there are, let's say, unknown behaviors that are coming out of a new malware that emerges, we may be able to more finely map to where it is falling in the n-dimensional space. Is that one use case that you have thought of?
Yes, that is one of the important. If you look at the right side, right, the cluster 0, if you look at it, almost 38,000 of data points were falling into cluster 0 without our attributes. But then once we've introduced our attributes, almost 10,000 of them have moved to another clusters, or maybe it got split into another cluster. So we saw finer patterns in the same cluster, so which actually might correlate to something that the existing attributes couldn't find. So yeah, that's
okay.
one of the use
Thanks.
cases, right? Yeah.
Okay, thanks.
I think that's a characteristic of also the DB scan or HDB scan, that it's a type of clustering algorithm. And yeah, go ahead.
But okay, so the difference from k-means and DB scan, right? Once in k-means, you'll have to actually mention the number of clusters you want to create. Like it's a pre-step. You'll have to first tell how many clusters to make, and only then it will make. But in DB scan, you need not do that. It will automatically create few clusters based on parameters like epsilon and minimum points. So that's why DBScan is also better, right? And also, if you look at it, K-means is more of centroid based. When I say centroid, let's say if there are patterns in a circle, let's just assume a circle on the graph, and let's say all the points are on a circle, that all the points on the circle belong to one cluster. So this can't be made on a K-means. It can only, but a DBScan will make that cluster. So DBScan is better in that sense because it's density based and not distance from centroid based. So it's more of density based. So yeah, DBScan is better in that sense, and also it implicitly gives us the number of noise points also. So that, like I said, that those noise points might be the flows which are malware. So these patterns have been extracted, and we'll have to work on it to actually map it to a particular class of malware, or do, yeah, we'll have to do that as further steps.
So you're saying the noise points may actually be, in other words, the unclustered entities might actually be indicative of some sort of malware? The non-cluster?
Yes, maybe, right?
Okay.
Yes.
Interesting.
They're not sure yet, but it could be the case, yes.
Yeah. I mean, that's how DBScan gets high-quality clusters, is because it doesn't try to cluster everything, and it leaves the zero cluster out there.
Yes. Okay. So the thing is, even in network, right? We like if it's a known network, we know what kind of packet lengths are going to be there. We know what kind of and like it's generally known. And once you say it's a malware data set, there might be different patterns of packet lengths inside that. There can be anything, right? It's generally chaotic. So that could be that. All those chaos points could be these noise points, and we could actually detect that malware using this. So yeah.
Interesting. Okay, any other questions?
I just had one. So if you subtract out traffic due to videos on the internet, does that affect your results?
Okay, that's something I'll have to explore, but then it should. I think it will, but that I haven't explored that at all. I don't know if.
Alan, what brings that question to mind? Why is that an important aspect?
Just that the traffic over the internet is starting to be video dominated. And so sometimes, when you're looking for anomalies or malware, that type of thing, you typically have to, de-emphasize the mean.
Yep. Thank you.
Okay. Yes. That's something. I mean, this could also be an application.
No,
in IoT
actually,
devices.
I have one insight to share there. I think if you can you go back 2 slides back where you have put the packet length. What are the feature? I think video has a typical characteristic of fully packed packet lengths, right? That 1400, 1400. It may not have all these toggles so much in the first place. Now that may be the property he may be saying. Even if there is a video traffic, it may still be able to see the unintended behavior, right? I don't know. This is just a guess. I'm just guessing whether that makes sense or not.
Could be. Even I'm not really sure.
Yeah.
Yeah. No, I didn't ask the question from a point of knowledge. Just a question. Question about a question.
Yeah.
Okay, I think that's time's up, and thank you for the presentation. And I'd like to thank everybody for participating. But I mean, before we end, are there any other questions anyone has for any, in general, for anyone on this call or for any of the presenters before we call it a call? Okay, thanks everybody. I think that'll end the lightning shares. So. Thank you.
Thanks, Darren. Thanks, everyone. That was awesome. just to wrap up, that was a great session. Thank you so much, Edgar, Kamal, Brian, Fatma, Ankit, Ashwini, Preeti, Nitin, and Darren for hosting. And thanks everyone for attending and for your questions. This video will be available on the session page, and this was kind of a cool experiment. So it was really cool to see so many people from the community coming through. And be sure to check out the session page if you want to review anything and join the community Slack. See you soon.